Area versus circumference of circles. You should have the problems in front of you. You glued them down into your notebook, but if you don't, go ahead and copy this problem down. A revolving water sprinkler sprays water in all directions to a distance of 10 feet. How many square feet of lawn does the sprinkler water? So what we need to do is, and then we're asked two questions. What measurement is this problem asking you to find and why? And then to solve it. So what we really need to do is visualize the problem. If we have our little sprinkler here, and if you think about a revolving sprinkler, it revolves around in a circle. So it basically makes a circle right here. And from the center, so where the sprinkler is to that outside edge, that distance is 10 feet. And we are asked to find how many square feet, that is a hint, of lawn does the sprinkler water. So if you can imagine, it's covering not just this outside or circumference of the circle, but the sprinkler is actually covering this whole distance inside the circle. So the measurement that we are asked to find is the area. And the reason that we're asked to find the area is that it covers a section of lawn. It doesn't go around a circular piece, it covers the lawn. All right, so that's why we are asked, why we're trying to find the area. Now the other clue there is square feet. Area is always measured in units squared because it's literally the number of squares that cover a space. So to solve this problem, what we're going to have to do is first start with the formula. Area equals pi r squared. So we are looking for the area. So we're going to substitute in 3.14 for pi times the radius squared. Well, 10 feet right here was the radius, so it's 10 squared. So 3.14, we're going to do our exponents first. 10 squared is 100, and then we multiply that by 3.14. And anytime we're multiplying by multiples of 10, we're just moving our decimal point over. So 100 times 3.14 is 314 feet squared, or square feet. And that's how much lawn is being covered. All right, next situation. A pizza shop sells a medium pizza with a diameter of 12 inches. So we know, I'm just going to draw it over here. So this is the medium, and the whole diameter is 12 inches. And it sells a large pizza. Notice these are not drawn to scale. A large pizza with a diameter of 18 inches. Joseph's favorite part of the pizza is the crust. How much more crust will he get by ordering the large pizza as opposed to a medium pizza? So let's think about this situation. We're asked to find the crust. Well, the crust goes around the outside edge of the pizza. So when we have to figure out whether or not we are finding the area or circumference, well, what does the edge cover? And the edge covers the circumference. So in this problem, we are solving the circumference. Why? Because crust is the outside edge. All right, so now we need to solve it. But in this problem, we actually need to do a couple of steps. First, we need to find the circumference of the medium pizza. So I'm going to put a lowercase m right there. And the circumference is pi times the diameter. So we're going to do 3.14 times the diameter, which is 12. And then when we multiply that out, we get 37 and 68 hundredths inches, because we're measuring in inches. So now we have to do the circumference of the large, which is going to be pi times diameter. So that's going to be 3.14 times the large pizza has a diameter of 18. So then when we multiply that out, we get 56 and 52 hundredths inches. Now it says how much more crust is he getting? So we need to find the difference between the amount of crust that he would get with the medium versus the amount of crust that he would get with the large. So what I'm going to do is I'm just going to show, because I'm out of space, I'm going to just show 56 and 52 hundredths minus 37 and 68 hundredths. And that gives us a difference of 18 and 84 hundredths inches. So let me rewrite that up there. 18 and 84 hundredths inches. He's getting a little bit more than 18 inches of crust if he orders the large pizza. Pause, rewind as many times as you need to understand. When solving measurement problems, you've got to be real careful. They are tricky. You've got to read carefully and visualize your situation.